Hello, Mr. Galay, and today we're going to learn an important concept in pre-calculus called polynomial function, and specifically we'll focus on zeros, multiplicity, and behavior, and graphing polynomial functions step by step. So I'm going to break down everything visually and logically so you can actually understand what's happening. Okay, so let's define what polynomial actually is. So a polynomial is an expression made up of a variables, coefficients, and exponents that are whole numbers. So here's an example. F of x equals x to the power of 3 minus 4x squared minus 5x plus 8. Okay, so this is clearly a polynomial because we know that exponents are positive and whole numbers. Like you could see 3, 2, and 1. So the highest exponent in the polynomial is called the degree. And as you see, like I circled, the degree of this polynomial would be 3. And the polynomial is called cubic function. Okay, so one of the most important parts of graphing is finding the zeros. So zeros are essentially the x values that make the function equal to 0. Basically, it's when the graph crosses the x-axis. So let's solve an example. F of x equals x squared plus 5x plus 6. Okay, so how would we solve that is set it equal to 0. I already did it, so it takes shorter amount of time. So x squared minus 5x plus 6 equals 0. You set it up to the 0. Then you would need to factor it out. In this case, that's how you basically approach every single that's how I personally approach every single factoring of the polynomial or an equation. What two numbers multiply to get a 6 and add up to get a negative 5? Well, clearly it's 2 and 3, right? For 6, because 2 multiplied by 3, is 6. Now 2 plus 3 is 5, not negative 5. Therefore we need to put a negative sign for each of those, because negative 2 plus negative 3 is negative 5. So you set that equal to 0, and then you do the same exact thing for this and for that. And so when you solve that, x minus 2 equals 0, x equals 2, x minus 3 equals 0, x equals to 3. So on the graph, those are the points where the polynomial crosses the x-axis. Now let's talk about multiplicity, because every single time it changes how the graph behaves near 0. So multiplicity tells us how many times a 0 repeats. Basically, what it means is, let's look at an example. F of x equals x minus 2 squared multiplied by x plus 1, right? This is a polynomial. Okay, so here, if we factor it out, x is going to equal to 2. Remember, x minus 2 equals 0, x equals to 2. Now, if we see the degree here, degree is 2. The multiplicity is basically the degree of this part of the equation. So if you have the exponent that's to the power of 2, then the multiplicity is going to be 2. In this case, if you don't see anything, it means it's 1, right? So the multiplicity for this part of the equation would be 1. Now, here's the important rule. So if the multiplicity is odd, the graph crosses the x-axis, like in this case. The multiplicity is 1, so it crosses the x-axis. If the multiplicity is even, so 2, 4, 6, 8, 10, etc., the graph touches the x-axis and then it bounces off. So at x equals to 2, the graph will touch and bounce, and then at x equals negative 1, the graph crosses through the x-axis. Next thing I want to talk about is end behavior. So end behavior tells us what happens to the graph as x becomes very large, positive, or very large, negative. So the two things determine our end behavior, and they are the degree of the polynomial, which is, as I explained, basically the exponent, and the leading coefficient. So let's look at both of those examples. So in example 1, we have f of x equals x to the power of 4. So this is an even degree polynomial with a positive degree coefficient, because the degree coefficient is 1. If you don't see anything, it's always a 1. So that means both ends are going to go upward. So it's going to start up and it's going to end up. Now let's look at example number 2. So f of x equals negative x to the power of 3. So this is a odd degree polynomial with a negative leading coefficient, because you see a negative right here, right? It would be -1. And then the odd coefficient, meaning is 3. 3, 5, 7, 9. These are all odd numbers. So the left side is going to go up and the right side is going to go down. So basically, to make this easier to remember, so even degree is same direction, odd degree is opposite directions. Positive leading coefficient, right side is going up, negative leading coefficient, right side is going down. Okay, now let's combine everything together. I'm gonna walk you through the example like how I would do this. So step 1 is always find the zeros. So what are the zeros here? Always take each part of the equation and make it equal to 0. X plus 2 equals 0. Well, the first 0 is -2. X minus 1 equals 0. X equals 1. X minus 3 equals 0. X equals 3. Right? It's pretty self-explanatory. I don't think I need to explain it even more. So now determine the multiplicity. This is always step 2. So that means the factor of x minus 1 means that when x equals to 1, it has the multiplicity of 2. For these other two parts, you don't see any exponents. So this is kind of simple. It's just going to go through the x-axis, meaning 1, 1. So the multiplicity here is 1, 2, 1. Now end behavior, okay? So if we add all of the exponents together, the total degree is 4 because 1 plus 2 is 3, 3 plus 1 is 4. Now the leading coefficient is positive, which is 1. So both ends of the graph go up. Now, leading coefficient is also positive, so both ends are also going to go up. Now, let's graph this all together. So we remember that end behavior is positive and leading coefficient is also positive, and then behavior is even. Therefore, both ends are going to face up, right? So now look at the zeros. So negative, let's mark it up. -2, 1, 3. Right? Now look at it. So when we have x equals 1, if we have, let's start from the beginning. If we have x equals -2, is the multiplicity odd or even? Well, clearly it's odd because we have a 1, so it's just going to go through like that. Now we're getting to the next section, which is x minus 1. Well, the 0 is 1, so is the multiplicity odd or even? It's clearly even. So what it means is we bounce off that spot. And now x minus 3. When x equals to 3, is the multiplicity odd or even? It's odd because it's a 1. So it just goes through. So this gives us a much more accurate graph than just simply guessing if it's going to go up, down, sideways, downwards, anything. Now, to wrap this all unit up, so zeros tell us where the graph intersects the x-axis. Multiplicity tells us whether the graph crosses or bounces. Degree and leading coefficient determines our end behavior, and all of those ideas helps us to graph polynomial functions accurately. So I really hope this lesson helped simplify polynomial graphing and made the concepts kind of easier to understand visually and hearing me explain stuff. Thank you for watching, Mr. Goulet, and have a great night.